Hi guys, in this section we're going to learn how to name aromatic compounds. What we're going to do is we're going to take a look at benzene, and you may recall that benzene is made up of 6 carbons and 6 hydrogens. These are mono-substituted. Okay, mono means one, substituted means you take something out and you put something else in its place. And so what we do in this case is we take off a hydrogen atom and we put a different atom in place of it. So in this case, the green represents chlorine. So we've taken out one hydrogen and we've put in one chlorine. We've mono-substituted this benzene, right? And the way you name these is pretty straightforward. If you put a chlorine atom on, it's chlorobenzene. If you put a bromine atom on, it's bromobenzene. If you had put a fluorine atom on, it would be fluorobenzene. If you had put an iodine atom on, it would be iodobenzene. So that naming should be pretty straightforward. But we can do this a little differently. These are still mono-substituted because we're substituting one of the hydrogens, right? There should be a hydrogen right here, but we've taken the hydrogen off. But now instead of putting one single atom, we've put a collection of atoms. A carbon and 3 hydrogens is called a methyl group, and you saw those in the first half of the chapter. Since the name of this is methyl, we could call this methylbenzene, and that would be perfectly acceptable on any test or quiz. Chemists often call this toluene. If you look in the notes, you'll see this referred to as toluene. So this molecule has 2 correct names, methylbenzene and toluene. This is a mono-substituted benzene because we've removed one hydrogen and we've put an ethyl molecule where the hydrogen was. Since this is an ethyl, we could call this ethylbenzene. This is also sometimes called xylene, but ethylbenzene or xylene. Still more mono-substituted benzenes. We've taken off one hydrogen and we've put this molecule. This is new. You haven't seen this one. Red represents oxygen. So the black is carbon, the white is hydrogen, the red is oxygen. If you go way back to chapter 4, when we learned to name molecules, an oxygen and a hydrogen was called hydroxide. And so one of the names for this molecule is hydroxybenzene. Chemists also call it phenol, and so either one of those would be acceptable. This used to be a hydrogen atom. We pulled the hydrogen atom off and replaced the hydrogen with this. This is an ethene molecule, an ethene molecule. This molecule is often called styrene. Benzene can be used as a substituent. In other words, in this molecule, the hydroxide ion is what is being substituted for hydrogen. The hydroxide ion is the substituent. In this molecule, the methyl group is substituted for hydrogen. The methyl group is the substituent. In this molecule, the ethyl group is substituted for hydrogen. The ethyl is the substituent. So the substituent is the piece that is being substituted. The substituent is the piece that's being added to the molecule. And a benzene can be used as a substituent. So rather than adding pieces to the benzene can be added to another molecule. And you're seeing an example of this right here, where benzene is added to a molecule. Or right here, benzene's being added. This R stands for the rest of the molecule, right? And so you can stick benzene onto other things. Okay, now we're looking at di-substituted. Di, of course, means 2. That means we're going to pull off 2 hydrogens and replace those 2 hydrogens with something else. In this case, we've pulled off 2 hydrogens and replaced both of them with chlorine atoms. The same thing here, except now the chlorine atoms aren't next to each other. There's one hydrogen between them. And in this case, the 2 chlorines are on opposite sides of the benzene from each other. And so what we need are unique names for each of these different formations. There's 2 ways to do this. And the first one is that you can simply name all the carbons, right? So just like we named carbon chains, we can name carbon rings as well. or pardon me, just the same way that we numbered carbon chains, we can number carbon rings. So this carbon would be 1, this carbon would be 2, 3, 4, 5, and 6. So we would call this 1,2-dichlorobenzene. This would be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. The name of this molecule is 1,3-dichlorobenzene. And finally, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. This is 1,4-dichlorobenzene. So you can always use those numbers. One thing to be aware of, it would be incorrect to number 1, 2, 3, 4, 5. So that if you name this 1,5-dichlorobenzene, that would be wrong. You say, well, how do I know? You always want to use the smallest possible numbers. So since 1,3-dichlorobenzene is smaller than 1,5-dichlorobenzene, 1,3 would be the correct numbering for that. Here's another way you can do it. Instead of using numbers, you can use the prefixes ortho. Ortho is going to mean that whatever is being substituted, in this case it's hydroxide again, are right next to each other. So instead of calling this 1,2-dihydroxybenzene, we can simply call this ortho-hydroxybenzene. The ortho tells us that these two things have to be next to each other. Meta. All right, now if it's meta, there's going to be one space in between them. So instead of calling this 1,3-dihydroxybenzene, we can simply call it meta-hydroxybenzene. And finally, para means that, well, here it is, whatever you're putting on the benzene has to be on opposite sides of the molecule. So instead of calling this 1,4-dihydroxybenzene, you could simply call it para-dihydroxybenzene. Both of those are correct. Using numbers is correct, and using the ortho, meta, and para prefixes are also correct. I remember this as Oscar makes pancakes, or Oscar makes pancakes. You can use that, or you can come up with your own mnemonic device to help you remember the ortho, meta, and para prefixes. Finally, there's no rule saying you can't stick rings together, and these are a few examples. There are many, many others. When you put two rings together like so, that's called naphthalene. It's the smell of mothballs. It's got a very distinct odor. Mothballs are becoming more and more dated as the decades go by. We don't really use them anymore. But this is naphthalene. This is anthracene. 1, 2, 3 of them. Anthracene, if you read the notes, it's kind of interesting. When the Roman Catholic Church elects a new pope, all the cardinals are locked together in a room called conclave. And if they select a new pope, I'm going to get this wrong, aren't I? I believe, I don't remember the color of smoke that means a new pope has been elected. It's white or black. But this is one of the molecules used, I believe, to make, I'm going to get it wrong again. Anyway, this molecule, anthracene, is used to make one of the molecules that tells us if a pope has been elected or if a pope has not been elected. And finally, this is called I believe it's called phenanthrene. You can check the notes and see if I'm forgetting that. I believe this is found in cigarette smoke. In general, these rings that are linked together, sometimes they're called polycyclic aromatic compounds, or PCAs. Poly meaning two or more, or many. Cyclic just meaning that they're made out of rings. Are usually dangerous. Quite often they're carcinogenic. What's particularly interesting, though, is that we've found these in outer space. Now, how that is done is really quite something. But it's pretty amazing to find these in molecular clouds of gas and dust, because those environments have a lot of radiation. One of the things radiation does is break molecular bonds. It breaks molecules apart. And that suggests that these are actually pretty stable, and that's consistent with what you learned earlier in Section 8 about how having these 6 electrons that can move around the ring, remember that's what those dotted lines mean, that resonance, that resonance makes benzene very stable. So these tend to be pretty stable molecules.